Hey everyone, welcome to my YouTube channel. This is Lolita, studying in Sri Venkateswara College of Engineering, SVCE, in the department Computer Science and Engineering. Today's topic is about creation of animated characters by the application of physics. In the subject Applied Physics, subject code VPHYS102. Topic is creation of animated character by the applications of physics. Contents: introduction, types of animation, application of animation, principles of animation physics, steps for creating realistic physics, simulations in 3D animation. Introduction. Physics-based animation has emerged as a core area of computer graphics, finding widespread application in the film and video game industries, as well as in the areas such as virtual surgery, virtual reality, and training simulations. One of the trends in visual media is an ever-increasing demand for realism and graphical fidelity. This is most visible in live-action works, and for a good reason. Types of animation: traditional animation, computer generating animation, stop motion animation, 2D vector animation, and motion capture. Application of animation: entertainment. It is used in features, films, TV series, video games, and web content to captivate audience and tell engaging stories. Advertising. Animated commercials and promotional videos are effective for conveying messages and attracting attention. Education. Animation is used in educational videos. Medicine and sciences. Animation helps visualize complex biological processes and scientific concepts. Principles of animation physics: timing, spacing and scale, law of inertia, momentum and force, center of gravity, weight gain and loss, action reaction. Now let us go in depth in all these topics. Time, spacing and scale. Spacing is the distance an element travels between two frames of an animation. Timing is used in animation to produce motion that adheres to physics rules and adds interest. Law of inertia. The law of inertia is a resistance of any physical object to any changes like starting or stopping a motion or changing direction. Momentum and forces. The principle of force and momentum says that an unbalanced force will change an object's momentum. The bigger the force, the quicker the momentum changes. For moving characters, this change in momentum could result in increasing or decreasing a character's speed, or it could be a change in direction. Center of gravity. The center of gravity is the average location of an object's weight. The center of gravity is important for various reasons. The path of action of a moving character, the point that we are most interested in tracking, is the center of gravity. Weight gain and loss. When a character is moving, its effective weight can be constantly changing. Specifically, if the character is falling and speeding up, rising and speeding up, rising and slowing down, falling and slowing down. Here in the picture you can see that the weight is lost when the character is falling and speeding up and rising and slowing down, and the weight is gained when the character is rising and speeding up and falling and slowing down. Next topic: action reaction. The principle of action reaction, also known as Newton's third law, states that when a character interacts with an object or with another character, both are affected. Steps for creating realistic physics simultaneous in 3D animation. 1. Choose the right software. The first step to creating realistic physics simultaneous in 3D animation is to choose the right software for your needs. There are many options available in the internet. Set the parameters. Once you have chosen your software, you need to set the parameters for your simulation. These are the values that determine how your simulation behaves and interacts with other objects and forces in your sense. Some of the common parameters you need to adjust are the mass, friction, gravity, and collision. Number 3. Optimize the performance. Creating realistic physics simultaneous in 3D animation can be very computationally intensive and time consuming, especially if you have complex or large scale simulations. Therefore, you need to optimize the performance of your simulation to reduce the render time and the memory used. Step 4. Add details and variations. One of the challenges of creating realistic physics simultaneous in 3D animation is to avoid making them look too uniform or artificial. To add more realism and interest to your simulation, you need to add details and variations that reflect the natural diversity and imperfections of the physical world. Step 5. Review and refine. The final step to creating realistic physics simultaneous in 3D animation is to review and refine your simulation until you are satisfied with the result. Conclusion. As technology continues to progress at a rapid pace, we can be certain that the future holds even more impressive achievements in this field. Still, we need to find an animated presentation tool that is both very general and easy to use. Computer animation has unlimited potential. Computer animation is a powerful tool to entertain as well as educate. Thank you guys. Thank you for watching the video. I hope you liked the information provided. Thank you.